So we have this very interesting question of geometry, and this question is taken from one of the Canadian math exam. It was conducted by University of Waterloo. So let's see what is given in the question and what do we need to find out. Let's understand the question. So here we are given with a large semicircle. Yes, and in this semicircle we are given n congruent semicircles. N congruent semicircles. See, this dot 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 indicates that this is continued. Okay, this is continuous semicircles. Congruent means all of them have the same radius. They start from one endpoint and goes till the another endpoint of the diameter of the largest semicircle. Okay, so there are n semicircles. And what is given? There are two areas given to us. First is area A, combined area of small semicircles. This gray area, if we add them up, we will get A's area. P area. Area inside large semicircle but outside small semicircles. So area inside the large semicircle but outside the small semicircle means this area. This area is B area. Okay. And we are also given the ratio of these two areas. A and B is 1:18. Correct? And what do we need to find out? We need to find the value of this n. N means the number of semicircles that are there inside this large semicircle. We need to find that, the number of small semicircles. Okay. So let's see how we can find the number of small semicircles. So first of all, let this be the center of the large semicircle and this be the radius. Let the radius of the large semicircle be capital R. If this is capital R, this is also the radius of the large semicircle, capital R. Okay. Now let's choose one of the semicircles. Let us pick up this semicircle. Okay. This one. Let the radius of this semicircle be small r. Okay. Small r. So the radius of all the small semicircles is small r because all of them are congruent semicircles. Okay. Now let's find the relation between the small r and the capital R. Okay. Now, what is the diameter of large semicircle? That will be 2r. Yes, 2r is the diameter of the large semicircle. Now, let us look at the diameter of small semicircles. Diameter of small semicircles. That is 2r. Now, what we can see? We can see that these semicircles are evenly distributed on the diameter of the large semicircle. Correct? That means n times small semicircles. Let's say n is the number of semicircles, n times 2r. This will be the total length of the diameters of all the small semicircles. This will be equals to 2r, capital R, because this is equals to diameter of the large semicircle. Yes. So n. So r will turn out to be r upon n. Okay. Please keep this in mind. We will be using this later on. Now let's come to A ratio B. Yes. A is to B. A is the area of small semicircles. Yes. So what is the area of one semicircle? Small semicircle. It will be pi r square pi 2. Pi 2 means half because pi r square is the area of the whole circle. Since it is a small semicircle, I mean it's a semicircle, so we divide it by 2. Now how many such semicircles are there? There are n semicircles. So multiply by n also. Yes. Now what is the B area? Area, this white area inside the large semicircle but outside the small semicircles. So what is the area of large semicircle? It will be pi r square divided by 2. Correct? If we take away the area of all the small semicircles, we will get the remaining area, white area, correct? So we will take away this area of small semicircles, that will be pi r square by 2 times n, correct? Yes. Now let's see what all things can be taken common and cancelled out. So first of all, we can clearly see this divided by 2 can be taken common and cancelled out. Pi can also be taken common and cancelled out, correct? Now we will be left with r square n upon r square minus r square n. Now this ratio was already given to us, that is 1:18. It was given in the question. Okay. Now what we can do, we can cross multiply and we will get 18 r square n equals to r square minus r square. Now this we can send on the left hand side and we will get 19 r square n equals to r square. Now in the next step we will be using this that we have found out earlier. Now if we use this, we will get 19. Instead of r we can write r by n whole square times n equals to r square, correct? And we will get 19 r n times r square upon n square equals to r square. Now r square and r square will get cancelled, n and n will get cancelled, and we will get the value of n, and we will get the value of n as 19. We will get the value of n as 19. This will be our final answer. This number of semicircles that we were asked to find out, it is 19. Yes, there are total 19 semicircles on this diameter of the large semicircle. I hope you enjoyed the question and you liked the solution as well. If yes, please like the video and subscribe the channel, and don't forget to share it with your friends.